third and final kinematic equation relates the velocities, the acceleration, and the distance. So it tells us that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in position. So it can be written as v squared is equal to v subscript y naught squared plus 2a subscript y brackets y minus y subscript naught. So this equation can be derived from the two previous kinematic equations. So let's have a look now at how we can derive this third kinematic equation. So to derive the third kinematic equation, we need to start with the second one. We've got y is equal to y naught plus v y naught t plus a half a y t squared. So this is the second kinematic equation. Now we can rearrange this. We can write y minus y naught, just moving this y naught onto the left hand side, is equal to vy naught t plus a half ay t squared. Now what we're going to need to do is use our first kinematic equation. So our first kinematic equation tells us that v is equal to v naught plus at. And so we can rearrange this to tell us that at is equal to v minus v naught. So what we're going to do is replace this ayt with v minus v naught. Now the y, that subscript just tells us that that's the acceleration in the y direction. So we can give this a subscript y and y naught if we want to as well. Okay, so we're going to substitute that in there. So let's call this one star and put sub into star. So we've got y minus y naught is equal to vy naught t plus a half. Now we replace one of these ayt's with vy minus vy naught, and then we're still left with one t. So we've got vy naught t plus a half vyt minus a half vy naught t. So you can see this will cancel out with that and leave a half vy naught t. So we've got a half vy naught t plus a half vyt, which is equal to a half vy naught plus vy times t. And that is y minus y naught. We haven't changed this side at all. Okay, now what we're going to need to do is actually rearrange the first kinematic equation again so that we have that time is equal to vy minus vy naught on ay. So what we can do is replace the time in this expression with the time from up there. So let's call this double star and put sub, now sub in double star. So sub is short for substitute. So we've got a half vy naught plus vy times vy minus vy naught, and this is all over ay is equal to y minus y naught. Okay, so now what I'm going to do, I'm going to multiply both sides by ay and also by 2. So we've got 2ay, y minus y naught, and so that's gone, that's gone. And so what we've got here is vy plus vy naught, just exchanging the order of that, vy minus vy naught. Now this is, we can write this as the difference of two squares. We can write this as vy squared minus vy naught squared. If you don't believe me, then expand these brackets and prove it for yourself. Okay, so we're almost at our third kinematic equation now. All we need to do is rearrange this with this. So we'll put vy squared onto the left hand side, and then we've got vy naught squared, this is moved over to this side, plus 2ay y minus y naught. And we've got there. This is our third kinematic equation. Okay, so let's now look at an example of how we can solve a problem using this equation. So, similar question to last time. A parachuter steps out of a plane 1.00 kilometers above the surface of the Earth. What is her velocity just before she hits the ground? And again, we're going to neglect air resistance. Poor parachuter, that would result in her going splat. So we've got, she starts at a height of y naught is equal to 1.00 kilometers, which is 1,000 meters. She ends up at y is equal to 0. Her initial velocity as she steps out of the plane is equal to 0. Her final velocity is what we're trying to find. We know that the acceleration is going downwards and so is equal to negative, and the value is 9.80 meters per second as this is on Earth. Okay, so we've got our equation v squared is equal to vy naught squared plus 2ay y minus y naught. Okay, so she starts off with a velocity of 0. So we can put that in as 0 plus 2 times minus 9.8. Now y, she ends up at 0 and she starts at 1,000. So that's how we substitute in there. And then this negative and that negative are going to cancel each other out. So we'll have 2 times 9.8, which is 19.6 times 1,000. So 19,600 is equal to v squared. And so v is equal to the square root of this. Solving that on the calculator, we get 140 meters per second. But we've been asked for the velocity, so we should give a direction. So this is towards the ground.